Probably should have grouped example I into the previous video, but whatever. It's really similar to what we just did. I'm going to do the longhand way first, where I'm going to write it as a multiplication problem. So everything that's inside the radical gets multiplied by itself. So negative 6 square root 7 will be multiplied by negative 6 square root 7. I'm going to multiply my coefficients, which would be a negative 6 times a negative 6. And when I multiply, two negatives turn positive. But I'm also going to multiply the numbers inside the radical. This is not addition. You actually have to multiply those numbers. 7 times 7 is 49. The nice thing is, when you square, it's not a coincidence that the problem on part G, we didn't have a radical in our answer. Part H, we didn't have a radical in our answer. We're not about to have a radical in this answer because radicals and squareds cancel each other out. And we're going to see this here because this is a perfect square. So you could go off to the side and try and remember that 7 times 7 is 49 and write out your work where you've expanded that to 7 times 7. But regardless, you're going to end up with a regular, plain as day 7 next to that 36 because the square root of 49 is the number 7. So if you catch that, jump to the 7 by all means. If you don't, or if you're just checking your work, actually write out what it is we're doing and why we're doing it. And then I'm going to clean up my work. 36 times 7 is 252. If you're trying to do it without writing it all out, because I know it's tempting because we all want to be lazy, remember, yes, you are squaring a square root, and those will cancel. You will have a 7 here. But you are squaring everything in this radical, and this negative 6 lives in this radical. So you also need to think negative 6 squared. And here's where another issue comes up. If you type that in your calculator, you're going to get the wrong answer because you mean negative 6 times negative 6. If you write this in your calculator knows order of operations and think you just want to square it and tack a negative on, and it's going to tell you negative 36. We don't want negative 36. Negative times a negative should be giving us a positive. So I'm kind of doubting whether I should have shown you this method in the first place. Honestly, sticking to this method is much more the foolproof way to do it. If you're wanting to guarantee you get the correct answers and you're getting the grade you want, write out your work and just make sure that you're doing it right. These last two in this little section are just throwing in variables with our numbers. So just adding an extra layer of complication to it. I'm going to start out the same way as always. I'm going to take whatever's inside my parentheses and I'm going to write it twice because squaring a number means to multiply it times itself. Then I'm going to multiply and simplify. 6 times 6 is 36. 7 times 7 is 49. And anything times itself is squared, so x squared. Now I need to simplify. I only need to simplify the numbers inside the radical. Outside I don't care about. So I can think of the 49 from earlier was a 7 times a 7, so my prime factorization is 7 times 7. X squared, remember, was x times x, so these are broken apart as far as they're going to get. So my prime factorization would also include an x times an x. Pairs make perfect squares. The square root of 49 is the number 7. X times x is just a plain old x. When you've squared something with a radical, you should not have a radical anymore. So it's not a coincidence that I'm not going to be writing that. That happens every single time. 36 times 7 is 252, and it literally took to this stage before I thought, this is kind of funny. Didn't we just do these numbers? I wasted a lot of time. This is almost identical to the last problem. It's missing a negative and it threw in an x. But really similar, slightly different results when you have the x in the radical, whatever. So the main reason that I prefer the longhand way when you're in an algebra class is because these variables are not easy to work with if you're just trying to think, oh, let's cancel stuff out. It's possible, and I'm not saying you can't do it. I'm saying you're more prone to mistakes if you try and do it. So I'm going to write it twice. Negative square root 7x cubed times itself, so times negative square root 7x cubed. I'm going to multiply, then simplify. So I'm going to start by multiplying the numbers inside my outside my radical. Technically, there's just a negative there, but remember, if you don't see a coefficient, you can assume that it is a 1. So there's a negative 1 times a negative 1, so that's just a positive 1. Inside the radical is a 7 times a 7, so we get another 49 to be working with. But then I have x cubed times x cubed. So as a reminder, cubed means I've multiplied x times itself 3 times. But I'm taking x cubed times another x cubed. So I would have 3 more of these x's here. So if you count up all those x's, I have 6 x's. So I've taken the I've taken the exponents. Wow, I could not think of that word. I've taken the exponents and added them. X to the 6th. So off to the side, I'm going to think of my prime factorization. The square root of 49 is 7. We know that. I just walked us through that twice. But when I think x to the 6th, I need to think what I just wrote out, where there would be 1, 2, 3, 4, 5, 6 x's. So each of these are broken down as far as they can. They join our prime factorization. So inside the radical will be 7 times 7 times x times x times x times x times x times x. Pairs make perfect squares. 7 times 7 is 49. There's a regular 7 outside the radical. X times x is x squared. Square rooting a squared number cancels. We get an x. This pair of x's gives us an x. This pair of x's gives us an x. So in the end, there's a 7, but now there's x times x times x. There are 3 of those x's being multiplied times itself. So if you want to try and think of that canceling out method, we technically did. This radical canceled this squared, and I'd had the 7x cubed. But there's no more negative, because squared means times itself, and we pointed out earlier, negative 1 times negative 1 canceled and gave us positive 1. That's why our answer is positive when we started out negative.